Hello, everyone. Well, today we're going to start our key features. So we're going to do this in a couple days because with key features, we're describing what a graph looks like. Okay, so there's so many different types of areas that we need to describe. And we're going to focus on going forward where we have a graph and we're going to state those features. Now, this helps too because we could always go backwards. We're going to do that at a later point. So today we're going to start with domain, range, X and Y intercept, and symmetry. So of course I have this covered because I don't want to waste time just writing the definition. I've already wrote it ahead of time. That way, if you need time to write it as I go forward, just pause the video and you can go from there. Okay. So let's do some definitions of these features. So we have domain, and we've worked with domain before, but specifically, I'm going to show you a different way how to do it, not just algebraically like we did with last chapter. So let's remember that domain are all the X values of a function. Then if we look at range, range is all the Y values of a function. The reason why I love this and I love math is mostly alphabetical is you can always remember that D comes before R, X comes before Y. Okay. Now let's go to our X intercepts. Hopefully we know these already, right? It's where the graph crosses the X axis. The other thing I want you to remember is it's a coordinate. Okay. Many teachers in the past have probably not been concerned with you just saying the X intercept is at 5. But we want to make it in a coordinate pair. So we need to remember that the X intercepts, and there could be more than one, there could be none, is a number comma 0. So Y is always 0. If you had to solve it algebraically, we would just set our function equal to 0 and solve. So that relates to our y-intercept. Our y-intercept is where the graph crosses the y-axis. So that coordinate pair is 0 comma a number. Does there have to be a y-intercept? No. But to be a function, there can only be one. So it's going to be none or one of them. Okay. Now this, of course, to find the y-intercept, we could do this algebraically also by just plugging in 0 for X and solving. And then one more thing, symmetry. Symmetry has a pattern or a kind of, I want to say pattern within itself. There's something unique about the graph that you could say about it. We're specifically going to focus on the symmetry of a function. Okay, there's symmetry of shapes, or closed graphs, but we are going to focus on a function, and we're going to label this as even, odd, or neither. Okay, so an even function, and by the way, you can prove even, odd, or neither algebraically. We're not going to focus on that right now because I want you guys to learn how to recognize it first, and either later on this year or next year, you'll learn how to do it algebraically. So even symmetry means that the function reflects over the y-axis. Okay, so when you fold your graph at the y-axis, it lays on top of itself. Okay, so remember, it has to be over the y-axis to be an even symmetry. And then we have an odd symmetry. Odd symmetry is where it rotates around the origin. The origin is the coordinate 0, 0. Okay, so example is our cube root here, right? So if I were to turn my paper upside down 180 degrees, I would have the exact same graph. And of course, neither means it's not even or odd. Okay, so these are the definitions that we are going to do. Now we're only going to do these things for each graph that we have. All right, where's my example form? Print. Or did it not do it in the correct order? Maybe I just did not do the right amount. I have a feeling my graph didn't print. Let's just go through these and maybe I'll see what happens later. Okay. Cube root. This is not a cube root. This is a square root. Sorry, guys. Okay, remember we're going to do domain, range, x-intercept, symmetry, and that's what we're going to focus on today. Okay, so domain are all the x values. So what I like doing when it comes to these x values here is I pretend as though we're going to flatten the graph down. Okay, we're going to flatten it. If we were to flatten it on the x-axis, as you can see, we would have a filled in circle at -4, and all of a sudden we have our arrow that continues to the right. So that allows us to say, hey, since it's a filled in at -4, and we go all the way to the right, well, what's all the way to the right? Infinity. Range, think of that same idea about flattening it onto the y-axis. So the lowest part I see, because the arrow makes it go up, right? The lowest part would be right here with the filled in circle, and our arrow would now be pointing up. Do you guys see that if I flatten it out to the y-axis? So where is this? Let's see, this is 2, so this needs to be the value of 1. So the lowest point is at 1 and it's filled in. So that's a bracket. And that arrow goes up. Up means infinity. All right, x-intercept, where it crosses the x-axis. Does this graph ever cross the x-axis? No, it does not. So we just say none. Y-intercept, where it crosses the y-axis, it crosses right here at 3. But remember, we're going to write it as a coordinate pair. So y-intercept is 0, comma, that number, and that number would be 3. All right, symmetry. Well, if I reflected it over, if I folded it at the y-axis, does it land on itself? No. And if I turn my paper 180 degrees, do I get the same graph? Yeah. So that means this is neither. All right, let's go to the next one. Yeah, I swear there was supposed to be another graph on the other side. All right, so this is our parabola. So domain, remember, domain is our x values. So imagine squishing this graph onto this x-axis right here. As I can see, the arrow would then all of a sudden be pointing to the left, and that arrow would be pointing to the right, which means the furthest left is negative infinity, furthest right is infinity. Now range, imagine squishing this whole graph onto that y-axis. As you can see, we have a lowest point at 1, and both of our arrows go up. Okay, so at 1, and it goes to infinity. Now, as you can see, I did not write a bracket or a parenthesis for that 1 because I want you to look at it a little bit. Does it hit 1? Is it filled in at 1? Yes, it is. So that means since it is filled in, we have a bracket. These are some decisions that you're going to have to take your time in making. Okay. X-intercept. Well, of course, right now, I swear the first graph had some x-intercepts, guys. Okay. It does not cross the x-axis, so there are none. the y-intercept where it crosses the y-axis right here at 7. So 0, 7. And symmetry, does it fold over the y-axis? No, it would fold over the 3, but that's not part of our definition, okay? And then would it rotate around the origin, which is right here? No, it would not. So this one's neither also. All right, this one's kind of crazy, right? Ooh, but it is a function, right? Because I could do the vertical line test. We only have one value for every x, okay? So domain, again, if I squish this on to the x-axis right here, right? Our arrow comes here, all these points are covered, and our arrow goes to the left. So again, it's negative infinity to infinity. Range, now be careful here. So if we squish this on, right? As I can see, this arrow squishes makes it go up. Do you guys see that? That arrow makes it go up. So it's going all the way up to infinity. But if we squish this, this arrow goes straight, so it's not down. So the lowest point is right here. You guys see that? The lowest y value is right here. So that's 1, 2, 3, 4. -4, right? And does it hit -4? Yes, it does. It's filled in. And as I said before, if we go up, we actually get an arrow that goes up. So it goes to infinity. All right. So in this case, our x-intercepts, we're going to have to kind of estimate a little bit, because as you can see, we have 3 of them. Okay. So let's just estimate these 3. Let's see. Oh, sorry, guys. The light went off. Let me pause. Sorry, kind of scary, huh? Motion detector. So, okay. So as I said before, we're going to estimate a little bit. Let's start at the left here. So remember, it's a coordinate pair and it's always a number, comma 0. So I know this doesn't exactly look like half, but let's do it anyways. 1, 2, 3, 4, 5. So this is going to be -5.5, comma 0. Our next one, let's do this as 1, 2, 3, -3.75. We'll keep it as kind of easy numbers. And our last one here, let's do this as 0.52. So that would be 2.5, comma 0. Now, hopefully in the future, I will give you graphs that are exact if I were to give you graphs. We're going to show you later how to use your calculator with this. But right now, assume you don't have a calculator and you got to get these key features out, okay? Y-intercept, where it crosses the y-axis, as you can see, there's only one where x-intercepts can have multiple. So 1, 2, 3. And don't forget, this is 0, comma 3. Symmetry, right away, guys, hopefully you're saying neither. We don't have to go through the reflection or rotation. All right. Uh-oh, what is happening here? I give you the function, but you do not have the graph. And then, like I said before, you're not using your graphing calculator. So we have to use what we learned last chapter in transformations to help us out. So this is an absolute value. So of course it's going to be a V, right? Think of your transformation. So it's going to reflect over the x-axis. It's going to move to the right 2 and up 3. Okay. But what we're going to do is use our parent function. So let's see if we use -2, -1, 0, 1, and 2. The absolute value of -2 is 2. The absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Okay, so let's see what we have to do to this. So remember, to the x value, we always do its opposite. So we're going to add 2. So we get 0. We get 1, 2, 3, and 4. For y here, we're going to multiply it by -1 and then add 3. Right, left to right. So -2, -1, 0, -1, -2. The great thing about doing this graphing right now is that once we do it, we don't have to do it again for our future key features. So we're going to add 3. We get 1, 2, 3, 2, and 1. So we're going to plot these outer points here. So 0, 1, 1, 2, 2, 3, 3, 2, and 4, 1. Did we go to the right 2 and up 3? And did we flip? Yes, we did. There we go. Okay, so now that we did our graph, we made our graph through transformations. Now we're going to do our key features. Okay, so domain. Think of our arrows, right? We squish it down to the x-axis. We have arrows going left, arrows going right. So -infinity to infinity. Our range. Now be careful, this one's a little bit different, right? Because if we squish onto our y-axis here, our arrows are pointing which way? They're pointing down. And then our highest point that I see on our y-axis here will be at 3. Okay, so the range, the lowest point, remember, because we always go least to greatest, is going to be -infinity. And the highest it goes to is 3, and it's filled in, so it's a bracket. Okay, we have our x-intercepts. I see 2 of them right here. So remember, that's a coordinate pair of -1, 0, right here. And then right here we have 5, 0. Y-intercept, where does it cross? It crosses at 1 right here. So that's 0, 1. And then we have symmetry. Let's see, it doesn't reflect over the y-axis onto itself, and it wouldn't rotate, because then we would have a right side up absolute value. So neither. Yes, most of your graphs will be neither, but once in a while we'll come up with something. Okay, and I'm pretty sure I did it here. Okay, another transformation. So this is an x squared, right? So it should be a parabola. Now we're going to move down 4, and it's going to widen, right? We're going to have that compression. So let's start with our parent function. Let's do the -2, -1, 0, 1, and 2. Now remember, this is the parent function, so we're squaring it. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Okay, nothing is happening to the x values. So remember, we do left to right. So I'm going to multiply it by 1/4 and subtract 4. So unfortunately here we'll get some decimals. So what I might want to do is find some extra points that work. Okay. And what might work? So I want to divide it by 4, right? So what if so I'm going to keep this here so you guys don't get confused. What else is divided by 4? That has a perfect square. 16, right? And that's at 4 and -4. So that would be 16. I'm just making it so we have some extra points. Okay, guys. So I'm going to multiply everything by 1/4. Okay. So this would be 4. This would be 1. This would be 1/4. This would be 0, 1/4, 1, and 4. Now I'm going to subtract 4 to all these numbers. I get 0, -3, -3 and 3/4. That's why we're not going to graph that one, okay? Because otherwise we're estimating, and that might mess up our x-intercept. -4, -3 and 3/4, -3, and 4 minus 4 is 0. Okay, so let me highlight, guys. I wish I had my highlighter. I'm going to graph -4, 0, -2, -3. I'm not going to graph the fraction ones, okay? Because I want to be accurate. So that's why I added on the 4. Okay, so -4, 0, -2, -3. Not graphing that one. 0, -4, 2, -3, and 4, 0. Now, remember when you graph these, this is a parabola, so round this out. Do not make it a V. Do you guys see that? I need to mark it more. There we go. All right. Now let's do our key features. So again, if I squish onto the x-axis, I have arrows pointing left, arrows pointing right, and everything in between works. So it's -infinity to infinity. Okay, range. Be very careful, okay? Range is going to be, if we squish it on, right? The lowest point is this -4 to infinity. Okay, -4, we filled that in, so that is a bracket. Awesome. Okay, x-intercepts, we have 2 of them. We have one at -4, 0, and the other one at 4, 0. Y-intercept, where is that? At -4. Remember, this is 0, comma, the number. And then symmetry. Does it reflect or does it rotate? It reflects. I know my drawing's kind of weird, but it reflects over the y-axis. So which one is that? Even. Awesome. Do your check for the day just to make sure, and then we'll move on.